Sachin. Okay, so as you all know, we have already covered the first module that was Excel, and whatever doubt you have, you can come individually and you can ask me. We will put our doubt clearing session as well, most probably next week, and then you can clear out your doubts as well. The next chapter, next module we are going to start is SQL. After this, we'll start with Python and then Power BI. So these four modules we have, and I will cover all of them one by one. Okay. So let's start with the SQL. So as you all know, SQL stands for Structured Query Language. Okay. Now, when I talk about SQL, so SQL is meant to interact with the data tables, right? Now, when you will go to various places, various database, various softwares, so there may be Oracle, there may be a SQL server, there may be MySQL or DB2 or Sybase, and many more. There are more than 30, 40 types of database packages are available. And data inside them are in the same manner, row and column manner. The arrangement is same. So for that, a standard language is used, which is common across all platforms. Means 98% commands are same, no matter what platform you are using. The SQL will be same for 98%. Just 2% there will be some platform specific commands are there, which will be working on particular platform only. But that is very very low, right? The 98% the commands are common for all the platforms. So we'll see that language. Now again, we are going to study about the language, not any platform. Okay. If you want to practice, there are free package available for MySQL also. You can install that in your system and you can practice. Or there are online compilers are also there. I'll show you those compilers. You can practice with those compilers as well directly. There is no need to install the SQL package or SQL software in your laptop. Okay. So today we'll cover a little about the theoretical part, some basic things about the database, because this is all about database management system, DBMS. If you might have interacted with any of your computer specific friends, they might have studied this subject called DBMS, database management system. So I'll just reveal few initial concepts of those, so that you can have an understanding of what actually it is. Okay. So basically, SQL is a standard language which allows you to access and manipulate the database, right? And this is, as I told, this is common and this is standard. So it can be used in any language. Then SQL standard stands for structured query language, and this is a NC standard started in 1986, right? In 1986, all these standards were created, and later on, it was standardized to the ISO also in 1987 to make it a common platform across all the database. This was something about the history of SQL that you need to know. Then, what SQL can do? So within the database, anything that you expect, SQL does that, right? So, for example, if you need to execute a query, you need to get some data out of the database, then you can use SQL. You need, if you get, if you want to do some operations over the database, you can do that using SQL. If you want to insert any new record into the database, you can do that. If you want to change any record based on some condition, or maybe not with the conditions, just there is a requirement to change, you can change that using SQL. Then anything that you want to delete from the database, you can do that. If you want to create a new database, that also can be done. If you want to create new tables in the database, that can be done. Then SQL can even create and create the stored procedures also in the database. And then SQL can create views inside the database. Everything that you want to do, SQL can do that. SQL even can set the permissions on the tables, on the views, on the procedures, because many times it happens that a lot of data that may not be available for everyone. So applying the security standards, applying the checks, applying the access rights, SQL is capable of doing everything. Although in many database for all these things there are drag and drop tools are available, which can be done just by single click of tool, but still SQL works in the background. So you can always use this SQL to do any task in the background with any kind of database, right? Okay. Then SQL, why SQL is very important? Because SQL is in just one line. SQL can do everything inside the RDBMS. It can do everything, right? Like providing access to the data. It can be done through query. Although in our course we are not going to see, because we are not going to work very much deeply on RDBMS admin part, because there are different types of roles are there. So when you will be working as a data analyst, most of the time you will be interacting with the database. Not means very rarely you will be allowed to change anything inside the database, and very rarely you will be allowed to do the admin part, like creating the permissions, creating the views and all. You will not be allowed to do all those things, because those are the admin level accesses are there, and those admin level accesses are not always allowed most of the time. And that's the reason you don't need to reach up to that point, right? Then you can describe the data using the SQL. Then there are procedures, there are database that can allow you to manipulate the data. Then you can embed the other languages with the SQL. So SQL commands are so friendly that even if you are using any other programming language, like you are using the Java or .NET or even Python, and with SAS also and R also, SQL is compatible with every other language that exists inside this development world. SQL has made because this is a standard, right? And that standard has been adopted by every single language, every single platform. So SQL is supported. SQL queries are supported, means exact query you can write anywhere in any platform, inside the any language. Like if you are using the Power BI, if you are using the Tableau, or if you are using any quick site of, and anything you are using, SQL query can be applied inside that, right? Libraries can be made along with the collation of SQL. So you can create and drop database, you can create and drop tables, you can create the views and the procedures, and you can and you can set up even permissions also. All these things can be done, and SQL, that is the reason SQL becomes so important, because no matter you are working on front end or back end, no matter you are working on the database directly as an end user, or you are working as an end user on the front end side, no matter you are working as a developer, or you are working as a data admin, no matter you are working as a data analyst or data scientist, no matter you are working either as a core analyst or just the occasional analyst, no matter what your profile is, SQL will be there in your life. SQL will be there at the part and parcel of your life. So you need to know this SQL very well, right? Being a data analyst at any platform, at any company, if you go for an interview, it is always expected कि आपको SQL आनी चाहिए. If you know the SQL, you you are eligible. Even if you know the Python and you know the Power BI, and if you don't know the SQL, people can say no to you, right? Because SQL is a common platform for the data interaction. And being a data analyst, data interaction is a very common thing. So it becomes very, very, very important. So always you need to deal with this. So when you are working with the SQL process, so what happens is here is a process diagram you can see. So whenever SQL query is passed, now this SQL query can be passed from anywhere. It can be passed from the front end coding side to the middle area, or it can be given directly on the SQL editor platform also. From wherever SQL query is passed, it is going to the query language processor. This query language processor, first of all, parser it and optimize it based on the need. And then this query language processor interacts with the DBMS engine, which is going to interact with the physical database. So this is the process of this SQL program. And once this physical database is connected, in the same way, in the reverse order, it goes, it generates the result as well. So it is same. It is very simple process. Simply from SQL query to query optimize to query processor, and query processor to DBMS engine, and DBMS engine to physical database. That's it. These simple steps are there. So basically, you can see these components are query dispatcher, optimization engines, classic query engine, and SQL query engines, right? So basically, there are different kinds of SQL commands are there. So out of that, first is DDL, data definition language, then DML, data manipulation, then transaction control. All these things are there. So let's see one by one. So first of all, there is SQL commands to interact with relational database. That is creating a new table, or creating a new view, or creating a new object inside the database. You use the create command. Means basically the commands through which you are going to define a new data. That is data definition language. Then second thing is alter, means you are going to modify an existing table, or you are going to make some changes into the table structure. Then it becomes the alter, means whenever you are going to change the table structure, that will be alter. If you are going to insert anything into the existing table, that will be insert. If you are going to change any existing value, then it will be update. And if you are going to delete, then it becomes the drop or delete command. Right? Very simple. From mean the commands through which the new data is either being defined or existing data is being changed. That's all are coming under the DDL, data definition language. Is that clear?
Yes, sir.
We'll all see these things in detail. If somebody is not able to follow, you can just be relaxed, because this is just first class. I want you to be thorough with the very basic concepts. So I am telling all these things. Otherwise, it is going to be purely practical from next class. I'll just tell you how to write the query and how to execute the query live, right? And then you can practice along with me. So no need to worry. You just understand that whatever I am telling over here. Okay. So second type is coming as DML, data manipulation language. What this data manipulation language is doing? So basically, data manipulation language is where you are interacting with the existing data, and you are trying to do some changes, right? So that is means access, select, insert, update, delete. Then there are transaction control language. So transaction control languages are like whenever you are using with the data, you are working on the data. What happens with the transaction control? What happens? It is all the transactions are not done in the real time, right? You might feel that the transaction is done on real time. Whenever you are doing any payment or any transaction, you might feel that it is done on real time, but actually in the background. It is not done on real time. There is a batch processing applied, right? And so that batch processing works with these kind of things, and that batch processing works in some equal intervals. Like when at initial level, when there was very less computing facilities, then those things used to run in once in every day. Then slowly it becomes twice in every day. Then slowly it becomes four times. Then now query runs in every 30 minutes, right? So like that, it is working. So for that, there is a grant command, there is the revoke command, then there is commit command, there is rollback command, right? So grant command is basically to allow the user level access, means how much part user can access for which area, and then revoke means getting permission back from the user, getting privileges back from the user. That becomes under the revoke command. Then apart from this, there is a commit command to execute the batch process on regular interval, and then there is rollback command. So whatever the commands has already whatever the transactions have already been done, just to apply those commands permanently over that database is a commit, and to back the to send the transaction back, this is rollback, right? So this is how all these things are being processed. Okay, any doubt so far?
Sir, can you please repeat rollback command?
So rollback command is a commit and rollback. Yeah. So like there is a bank in which transactions are done for means a batch is running in every 30 minutes, right? Suppose if a batch is runs in every 30 minutes to make the changes permanent, right? Now within 30 minutes something unusual is observed, and during that 30 minutes I want that no transaction should get through, and all the transactions should be back. So for that, uh, rollback command is used. So during that 30 minutes, all those transactions which are applied, which are done, that will be undo to the previous status. All the transactions will be cancelled. That is the rollback command. Okay.
Yes, sir.
Did I make it clear?
Yes, sir.
Okay. Great. Now I'll move to some RDBMS concept. Let me know when you are able to see my screen. Okay. So RDBMS concept, there are few very small concepts are there which are common, and I have tried to keep it as simple as possible. So do not worry about the bigger terms. I'll try to make it as simple as possible for you so that you can understand the basics, right? So RDBMS basically stands for Relational Database Management System, right? This is the full form of RDBMS. Then it is a basic basis for SQL. Means on this all SQL commands are run, and it may be Microsoft SQL Server, it may be IBM DB2, it may be Oracle, it may be Microsoft Access, it may be MySQL, it may be Sybase. Anything, any DBMS system is there. SQL is common for all those languages, right? Now, since it is a RDBMS, so RDBMS always follows the relational model. Relational model means now all the tables will be working in sync to others, in synchronization with others, right? Now no table will run alone, right? So all those all those tables which were, you might think that this is a different table that may be different table, this may be different table. Be sure that all those tables will be relational, and how those relations will be maintained, we'll discuss in some time how those relations are being considered. So for example, if you see this table, so you know all this table. So in this table, this id, name, age, address, salary, these are the columns. And this 1 2 3 4 5 6, then Ramesh, Ketan, Khilan, and Kaushik, all these are rows, right? You all know all these things, so I don't need to repeat that again. So what is field for or what is column? ID, name, age, address, salary. All these are column. And what is record? The entire one entity is called record, right? Then there can be null values. So null values are those which might be missing values are the null values, right? Wherever the appropriate value is not available, it may be the character value, or it may be the string value. Wherever the value is not available, we call that value as null value. Now, the important part comes is till now what we were discussing was tables are not working now in alone. They are going to be related with each other. So those relations are being done through the SQL constraints, right? These constraints are the rules that are enforced to maintain the healthy relationship and accuracy of data and reliability of the data, right? These are not the rules to make the stuff. These are made to make the data integrative, right? When the data works in the integration, this becomes a asset for us, right? Because it may give you the accuracy, it may give you the reliability, it may give you the ease of access, it may give you the pooling of the same type of data at one place, right? So these constraints are few rules that will be applied on the maybe on the column level or maybe on the table level, right? So column level are the constraints which are applied only on one columns, right? A table is there, inside that one column is there. So constraint will be applied on just that one column only, right? And in the same way, table level constraints will be applied on entire table. What these constraints are, what these rules are, we will discuss those in a short while. But for now, you need to understand that what is the constraint, right? Somebody may feel that if we will apply the rules, there may be the structure may get complicated. But trust me, this is not to make the structure complicated. This is done to make this entire structure available to available for general um, process. Okay, so there are few constraints. Those constraints are not null constraint, default constraint, unique constraint, primary key, foreign key, check constraint, and index constraint. So one by one, we'll see what all these constraints are. So basically, first of all, there is not null constraint. So what is this not null constraint? Not null constraint is to ensure that any column which requires some value to be there, it should not be blank. For example, if you have a table and that table has the employee records, right? Now, in employee records for any employee, name can never be blank. His contact information or address can never be blank. His maybe age can never be blank. So all these things are there which are mandatory to identify the uniqueness of that person, right? So until unless a name is not there, how will you identify? Until unless age is not there, how you will be identify that whether this person is eligible for the job or not, right? So this becomes very important to identify, and because of that. you cannot leave this name field or age field as blank. Okay. So any field which can never be left as blank for any kind of record is called under not null constraint. If anything, suppose there is any database in which name is blank, then that database can never be trusted, because the value that is required for a for a particular processing, if it is not available, how you can trust on that data? Are you getting my point? Are you able to connect with me?
Yes, sir.
Okay. um I'm sorry, मैं continuously English में बोल रहा हूँ. Everyone is comfortable with that? Is everyone comfortable with this? Anyone who is not comfortable, just you can raise your hand so that and कोई भी ऐसा जो मेरी लगातार इंग्लिश बोलने से कंफर्टेबल ना हो, तो आप मुझे बता सकते हो, बिकॉज जब भी मैं फ्लो में होता हूँ देन मोस्टली इंग्लिश ही निकलती है मेरे मुंह से. Okay, and when there is no issue, I can go on completely. Okay, so next constraint is default constraint. So default constraint is, for example, if any value is not specified or not given by the user, right? So for that, one value will be assigned automatically from the database side. So that will be the default value, right? So, so that there should not be a blank in that, right? Then third thing over here is unique constraint. Unique constraint is, it ensures that all values under that column are unique. Unique means, for example, if employee ID is there for any employee in the company, so it must be unique, no matter whether that employee is working currently or he has worked previously. For everyone, that employee ID will be unique, right? That it is not that one employee has left the company, now that ID can be given to some new person. This cannot be cannot work, right? So unique constraint is the value which is unique for entire column. Understood? Then primary key. Primary key is the unique identify. Now, since we know that this a particular value which is there, that is unique and it is not null. So for primary key, there are two constraints applied automatically. One is unique and not null. Two constraint, if you apply any column as a primary key, so it cannot have the duplicate value and it cannot have the blank value, right? Because it is the unique identification of every record. So when it is a unique identification, it can never be blank and it can never be repeated, right? So primary key of any table, for example, employee ID is there. So employee ID must be unique for every employee and it cannot be blank. If there are products in the company, so product ID can never be blank and it can never be repeated, right? Or if there is a roll number of the students inside the university, right? So roll number or allotment number or registration number can never be duplicate for any student, no matter whether he has studied 50 years before in the university. The roll number will always be unique. So that is all about the primary key. Okay. Then the foreign key. Foreign key is a unique identification which refers to the connection in any other database table, right? That becomes foreign key. So foreign key is used to connect the current table with another table in order to get the correct value. Then check constraint. So check constraint ensures that all values in the column satisfying the certain conditions. For example, if there is a gender column is there, so for gender column, only three values are required. Either it can be male, or it can be female, or it can be trans. Any fourth value is not allowed under that column, right? So that check can be applied, right? For example, another example, if amount is there, right? Amount, or you can say fees is received. So the fees received cannot be in the characters. No one can say that XYZ fees has been received. It should be certain amount, right? So that is also a constraint, right? That is check constraint. Or apart from that, if there is suppose a roll number of students in the university, so it must be in certain format, right? So that format is already defined by the university. No student can have any format other than that defined format, right? So that's what is the check constraint. So whenever database is prepared, whenever the table is prepared, these kind of checks are applied. Clear? And then there is index. Index is used to create and retrieve data from the database very quickly. So, for example, when we have a very lengthy table, so table is arranged in a certain manner so that the database retrieval can be faster, right? So, database retrieval in the sense like suppose there are 10 million or 100 million records are there in the in terms of transactions, right? Now, if you have to search a particular transaction using the transaction ID, so if you did not arrange the data with the indexes, it may take a major amount of time to find that transaction because it needs to search that transaction ID in the entire table. But if you will apply the index, it will divide the entire table into certain segments. And whenever a searching roll number is passed, it will search that roll number into that related segment only. Then it will not search that value in entire table. And that's how it becomes the indexed value, and it um, and it becomes important to understand how this works, right? So whenever you will start applying, you will be working on the um, live tables, so you will get to know what is indexing and how useful it is. Okay, any doubts so far? Do you, anyone who wanted to discuss anything out of this? Any question around? Any question? Okay. So here now there are some integrity concepts categories are there. One is the entity integrity. So integrity means whenever the primary key or unique key has been applied, there can be no duplicate rows in the table, right? So the primary key or unique primary key constraint or unique key constraints are just applied on the column level, but the entity integrity is applied on the entire row. It ensures that there are no duplicate records in the table. Then domain integrity is to enforce that all valid entries are given by restricting the type and format and range of values, so that when somebody is selecting the date, he is not selecting the 29 February 2025. Understood? Understood? Then third is referential integrity. So referential integrity is suppose if you have made the connection of one column with other column. So until the related table is available, the initial table cannot be deleted, right? That's how this referential integrity works. And then user defined integrity is enforcing the specific business rules that do not follow into the entity domain or referential integrity. Right? Means based it is depending on the business. Like if you are working for the banking, so what should be the transactions and how which type of transactions can be there, and in what segment, all those things are the user defined integrity. Okay. Then there is database normalization process is there. So this database normalization process is to increase the efficiency of the data, and basically it targets to eliminate the repeated data or redundant data, like storing same data in more than one table. Means same thing is stored in one table, second table, third table. It ensures the normalization process, right? Then ensuring that data dependencies that are being created should be making a very common sense, right? Both of the reasons that we discussed above are really important to reduce the overall size of the database, or and then the accessing level, so that easily all things can be accessible, right? So these are, there are multiple normal forms are there: first normal form, second normal form, third normal form, bcnf normal form. All those things are there. Although these all normal forms are not there under the scope, because you are not going to, no, you are not going to create the database over here. You will, yes, you will learn how to create the table. You will also learn how to insert the table, how to insert new record, how to update the record, how to alter the table. You will learn all those things. But doing all these things now, doing creating the relationships, or creating the normalization forms, all these are the job of the database admin. Being a data scientist, you usually don't get chance to work under the work as a database admin, so you will not get all these things to be interacted. But yes, this is important for you to know that all these things are there, right? If you demonstrate these things, it becomes a plus for you. Okay. Any doubts so far? Any doubts so far? Yes, no.
No, sir.
Any question? Sachin, Tanvi, Diksha, Suhani, Raj. Any question? Oh, I'm surprised that no one has any question. I'm really, am I that good?